In a recent podcast with Pieter Abel, Andrej Karpathy, Tesla's AI lead, discussed his background, Elon Musk's superpowers, and how Tesla is achieving the seemingly impossible, fully autonomous driving using only vision. Let's dig into this great interview. Hey y'all, it's Dr. Know-It-All. First of all, lols about me just saying in the very last episode up here that Andrej hasn't spoken out much recently. Well, proven wrong instantly. How about that? Anyway, this podcast series is called Robot Brains with Pieter Abel, or Pieter Abel, something like that. I believe this is the very first episode in his podcast series, and given the quality of this first episode, I would say you should definitely go out and subscribe. I can't even come close to hitting all of the points in the episode itself. It's about 67 minutes long, so I highly recommend. It's in the description. Go check it out. Definitely, listen to it while you're driving or working out or taking your kids to soccer practice or whatever. You should definitely listen to the whole one. I'm just going to pick out what I found interesting about the episode and try to explain a few things that might not be super clear to the layman, and so we'll go from there. So first, Andrej talks a lot about his background and he coming from Eastern Europe and going to Canada, and then by way of Canada to the United States, and finding work with OpenAI at first, and also of course being a researcher at Stanford. He was very famous for developing the first sort of deep neural network class in 2015, which is still going on as far as I know. And then of course his relationship with Elon Musk and how they got together and how he ended up working at Tesla for about the last 4 years. But what I think is a little more pertinent to this channel in particular is the background about computer vision. What I don't think a lot of people know is that computer vision, it started a long time ago. Self-driving cars was a task that I was watching people doing in the 1980s and 1990s. At the time, it was, I don't know if you have a robot vacuum cleaner, but it was very much like that. The thing would kind of go along and it would go, it would drive along in kind of crazy ways and it would make big mistakes. The problem is, and we're going to get more into this later in this episode, is that the world is really complicated, and these things could do okay in toy scenarios, but they just couldn't do well because human beings were coding everything. They were doing all of the work. And what happened was in 2012, Jeff Hinton and other people in his group came out with a deep neural network, and I've done a bunch of videos on all this stuff, so definitely check out for more details. But they came out with a neural network model that totally crushed anything else on image recognition in just 2012, right? 9 years ago from when I'm filming this. So anyway, in 2012, the state of the art was incredibly labor intensive. Human beings had to be involved in all parts. They wrote the code explicitly, and deep learning was not used. And of course, Hinton and everybody and ImageNet changed all of that. So anyway, that's kind of the background in terms of the way that deep neural networks and convolutional neural networks have sort of taken over so many tasks, but particularly the autonomous driving. And then Dr. Karpathy talks about how his relationship with Elon Musk is, and it's really interesting. I didn't know this, but apparently Tesla's sort of tenure for higher up executives is only about 6 months. So according to Andrej, it's sort of like a lot of people get there and a lot of people burn out. He said that he had a house in, or an apartment, something in San Francisco that he didn't even give up because he was like, I won't even be there that long at Tesla. Thank goodness he's still there 4 years later, because he says that he and Elon Musk really gel. And, he said one of the things is that Elon Musk wants to make the future good. And I love this. That's a wonderful sort of North Star idea, is making the future a better place than the present. I mean, what better overarching goal could there be? And this makes sense for the Boring Company, for Tesla, for SpaceX, for Neuralink, etc., etc. It's all to try to make the future a better place than today. Andrej Karpathy also discusses Elon Musk's superpowers. He says the biggest thing is intuition. In other words, he does really well with limited knowledge. So as Andrej says, Elon's not overwhelmed by the details. He's willing to take a chunk of knowledge that he has and make an intuitive leap. And I will add a synthetic leap. I think that's one of the major benefits that very bright people have, is the ability to synthesize different areas of knowledge and leap to conclusions very rapidly. And clearly, at least according to Andrej and from everything I've seen, Elon Musk has an amazing ability to do this with only minimal amounts of input data. He's able to come to a very, very good solution. The sort of scary part, according to Andrej Karpathy, is that Elon Musk wants the future yesterday, and I'm sure that comes as a surprise to no one who has seen his work. He's constantly pushing people to the limit because he wants to get there already. So according to Dr. Karpathy, you have to have the right attitude to work with him, and fortunately he does. He says he thrives on this sort of energy input. He almost likens Elon Musk to like the heat amount for an engine. He keeps talking about him providing energy to the system. So it sounds like he kind of blows in. He says, we need to do this stuff, and he really pumps up the room and he gets the flywheel going, and then people go out and they work extra hard for him. Also of interest, Andrej talks about how Tesla really likes to make cars that look like future cars. They're trying to make something that doesn't look like a current car because they want people to think about Teslas as the future, right? So battery electric vehicles and autonomous driving is the future, and so they need the cars to look like that. And I will go on, I'm going to do a video about this soon, so subscribe if you're not subscribed, about the UI and UX, so the user interface or user experience of people in a Tesla. I think that's not given nearly enough credit. I think Tesla is really pushing the boundaries on an industry where everything was kind of the same for decades. They're saying, no, we can redo this, right? That first principles thinking that Elon Musk is famous for is like, why do we have to do it this way? Why can't we do it this way? So I'm not just talking about like the shape of a Cybertruck or something. I'm talking about the interior and the interface and the way that we interact with the car. So anyway, I'm going to do an episode on that later, but I think it's a really important point to think about. Karpathy talks about how Musk really, really wants Teslas to look like the future. So then the two of them get into the specifics of, we're like getting into the weeds a bit about how Tesla's vision system works. I really like this. Andrej Karpathy says that driving is not a good use of the human brain. He's like, it's a path following algorithm. So basically what he's saying is that we spend an awful lot of time driving our cars and expending energy and mental energy to do that, which could be utilized more effectively to do something else. I hadn't really thought about it like that, right? You think about people working in factories and doing really dull jobs like, I don't know if you've ever seen the movie Metropolis. It's a wonderful movie. If you haven't seen it, you should see it. It's from the 1920s. And there's like this drone workers that go and they do the same thing. They're always turning the same screw or they're moving the same lever over and over again. And that sort of activity, that kind of thing that can be automated, and a lot of that has been done already in the situation of like factories and stuff, allows human beings to occupy themselves with more creative and interesting tasks. And Karpathy's putting driving into that realm, which I find fascinating. He's basically saying that if we don't have to concentrate on driving, we can do something more interesting with our time. Also very interesting, Karpathy says that Elon Musk sees AI as a fundamental pillar of a lot of their technology. So that's interesting because it probably means that AI is currently being used and will be used in a lot more contexts than we might think about. We think about full self-driving because that's an obvious one, but maybe the machine that builds the machine, they're using AI to help them create factories and to streamline factories and such. That's really cool that Elon Musk is thinking about using AI in as broad a sense as possible. So anyway, let's get into the weeds of this a little bit. Andrej Karpathy says, and I completely agree with this, that the more variable the input data, the more difficult the problem for computers. So full self-driving is a particularly nasty thing because there's a lot of variability to the input data, right? I mean, the same exact scene, right? The same intersection under night sky, under sunny sky, under cloudy sky, under rain, under snow, under fog, et cetera, et cetera. All of those things change the scene radically, and that's the exact same scene, right? So you could drive up to the same intersection in your neighborhood over and over and over again, and almost never is the lighting exactly the same between them, or almost never is the situation because a car might be there or something. So that variability is a massive problem because computers are really, really good at identical behavior, right? If you give it the same input in a Microsoft Excel spreadsheet, it's going to give you the same output. They're really, really good at that, but they suck at being flexible. And that's what is necessary for full self-driving. That's an amazing thing to, consider, is we're trying to force a computer, which is really, really good at doing exactly the same thing over and over again, to do something with flexibility in mind. Karpathy talks about how neural networks are not born with all of the stuff that humans have. I, to some extent, disagree with this. He talks about how we have persistence of memory or persistence of vision, et cetera, from birth. But I think this is all learned over time. You don't have that when you just pop out, right? You're not born with all of this stuff. It takes learning and interaction with the world. But we do, I think, have a lot of cheat codes if you want to think about it in terms of games, right? So we have a lot of stuff built in that will help us learn very, very rapidly, but we don't know that from the get-go. And I think it's important to understand that neural networks are not quite as far away from human brains as sometimes people say. Now, I know they're not the same at all, but I think sometimes people think that they're totally different, and I don't think they're as different as people think sometimes. Anyway, in the learning process, more variability leads to more needs for data and more need for training, which means that if you had the same exact scene and the same lighting over and over again, you could learn that pretty quick. But that exact scene with all the different lighting and weather conditions and other cars and dogs and people, etc., causes you to have to train many, many, many more times to learn about all those different circumstances. Karpathy talks about how they use a brute force method.
So the neural net is implementing a completely random function. It's doing completely random things, and it's starting basically from scratch. And you have to tell it what to do in every situation. And the more situations you have, the more you're going to have to give it in order for it to do the right thing in all the cases.
So Andrej, when a neural network starts from scratch and you put that neural network on a Tesla, what would happen if it drives that Tesla?
Well, you'll get random behavior when it's from scratch. It will be completely random behavior.
Got it. So it starts not knowing what to do. So you probably don't put those on the cars, actually.
No, you wouldn't want to do that.
And so you deal with all this variability and you want this neural network to internalize that variability. What makes a neural network internalize that variability? What's the solution to that?
So it looks like we do it through roughly almost brute force ways right now. So if I want the neural network to function in millions of situations, I need to plug in millions of examples or something on that order. So the neural networks do show some ability to sort of interpolate between the examples you've given them. They're not as good at extrapolating, but as long as you sort of cover the space of possibility and tell the neural network what to do in those different scenarios, they have some ability to interpolate between examples, but it's limited. And so if you really have a massive amount of variability that you want the system to perform well on, you actually have to cover that space to a large extent.
So this is very interesting, and it is state of the art, but I personally wonder if there might be a better way to do this. I really feel there's a room for a paradigm shift in the way that we train things and potentially synergistic synthetic cross knowledge, training, etc. So anyway, it's not synergy. I hate that business term. But anyway, I think that there potentially are other ways to teach computers besides the way that we've learned how to do it. We kind of have the nuns at a convent cliche right now, where the nuns are walking around with a ruler just going smack, smack, smack on the students. And that's not necessarily the best way to learn something. So anyway, it's an area of research. And I would say if anybody's interested, by the way, contact me, because I have some potential ideas about other paradigms for training neural networks as opposed to just the negative reinforcement method. One thing I think that is great is that Andrej talks about a metaphor for neural networks as having a whole bunch of little mathematical knobs that you can tune. He talks about how you would tell your parents or your grandparents how a neural network works.
Let's use a specific example because I think it's useful. So let's talk about image recognition, right? So we have images, and images are made up to a computer of a large number of pixels. And each pixel just tells you the amount of brightness in the red, green, and blue channel at that point. And so you have a large array of numbers, and you have to go from that to, hey, it's a cat or a dog. And typical conventional software is written by a programmer, writing a series of instructions to go from the input to the output. So in this case, you want someone to write a program for how do you combine these millions of pixel values into, is it a cat or a dog? Turns out no one can write this program. It's a very complicated program because there's a huge amount of variability in what a cat or a dog can look like in different brightness conditions, arrangements. Deep learning is a different class of programming, in my mind, where no one is explicitly writing the algorithm for this recognition problem. Instead, we are structuring the entire process slightly differently. So in particular, we arrange a large data set of possible images and the desired labels that should come out from the algorithm. So, hey, when you get this input, this is a cat. When you get this output, this should be a dog, and so on. So we're kind of stipulating what is the desired behavior on a high level. We're not talking about what is the algorithm. We're measuring the performance of some algorithm. And then roughly what we do is we lay out a neural network. It's a bunch of neurons connected to each other with some strengths, and you feed them images and they predict what's in them. And the problem now is reduced because you're just trying to find the setting of these synaptic strengths between the neurons so that the outcomes are what you want. The weights of the neural network were really 60 million knobs, and those knobs can be arbitrary values. And how do you set the 60 million weights so that the network gives you the correct predictions? And so deep learning is a way of training this neural network and finding a good setting of these 60 million numbers. And so roughly the neural network sort of looks at the image, gives you a prediction, and then you measure the error. It's like, okay, you said this is a cat, but actually this is a dog. And there's a mathematical procedure for tuning the strengths so that the neural network adapts itself to agree with you.
So as you heard, you can think of neural networks as mathematical knobs. I personally, because I have an audio background, think of an audio mixer as a really great analogy. So of course, this is all done in software nowadays. Well, mostly it's actually, but anyway, you look at like an old analog audio mixer and it has a whole bunch of knobs and sliders that you can adjust. And the input is a microphone or a line input from an electric guitar or something like that. And so you get all of these inputs. Now you would have millions of them instead of tens of them as you do with audio. But basically you take that input and you move a bunch of knobs and you adjust the faders and so forth. And what you're looking for is a pleasing output. You're listening with your ears. So the human being is at the center of this because the human brain is processing the fact that it's like, that's not what I want to hear, and then adjusting things that took training, right? The brain took training and it's like, okay, I'm going to adjust these different things to make this sound more pleasing to my ear. But that's basically what a neural network is doing. It's saying like, I'm predicting what's going to happen. It's not happening. I'm going to fix that. Let me just make some adjustments. And the making of the adjustments is a really big deal. Like how that's done is really complicated, but also super cool. But anyway, as with the audio mixer, what you do is you tune these things, and by tuning them to the right numbers, you get a pleasing mixture of things and you get an output that is correct or enjoyable or whatever for audio. But it could be considered to be the ground truth or close to that in terms of neural networks. One thing I found super interesting was that Andrej talked about software 2.0 in a general sense.
And so deep learning is basically a different software programming paradigm where we specify what we want, and then we use sort of mathematics and algorithms to tune the system to give you what you want. And there's some design that goes into the neural network architecture and how do you wire everything up. But then there's also a huge amount of design and effort spent on the data sets themselves and curating them. And, because those data sets are now your constraints on the behavior that you are asking from the system. So it's a very different way of approaching problems that was not there before. Everything used to be written by a person. Now we just write the specification and we write a rough layout of the algorithm, but it's what I refer to as fill in the blanks programming, because we sort of lay out an architecture and the rough layout of the net, but there's a huge amount of blanks, which are the weights and the knobs. And those are set now during the training of this network. So that's, I think, the bird's eye view of how this is different.
I had always thought of software 2.0 as a very specific thing in terms of the way that Tesla's full self-driving neural networks were working. But the way Andrej talks about it, it's not just Tesla, but a whole class. It's going from an explicit coding paradigm to a general architecture and training paradigm. So software is writing or optimizing itself. Very, very cool, super different from the way things are traditionally done and probably mostly taught in computer science programs still. But I think that's incredibly valuable information to realize that Andrej is not thinking about software 2.0 as a Tesla thing, but as a universal thing, where we're moving from that explicit coding by humans to human beings building an architecture and then throwing data at that architecture and letting it train itself and figure out how to do the best job it can. So at this point, we get to what everybody who knows about neural networks is probably thinking about, which is data. As Andrej Karpathy says, data becomes king, and quality data is the key. You're not making code anymore, you're training a brain. And bad input and bad output, of course, leads to bad education. And as a teacher, I kind of like this, right? We're talking about teaching this thing, and it's a student and it's learning. And so you have to give it quality input and quality output for it to really learn properly. As Karpathy discusses, there they're around 75% now data curating and only really 25% really working on the new architecture, the new neural networks and so forth. So that's really interesting. I think that there's a lot of the work on data curating trying to get humans out of the loop. In other words, having us touch the data as little as possible so that he's talked about this before. Again, I've got a whole series on that, but he talks about how the idea is for the software to go and identify a problem and then find examples of that and then teach itself on that, all without humans having to be involved in it, or Operation Vacation, as they say, where the computer is just teaching itself and they don't even have to really worry about it. Anyway, that 25% figure for software rewriting is really interesting because the version 9 beta software that's coming out soon is going to be a massive rewrite. So it's interesting that you've got this massive rewrite happening, whereas he still says that most of the effort that's put in is on data curating. So a rather interesting weighting of the two different factors involved in teaching computers to drive. One thing that Karpathy talks a lot about is how many variables there are to self-driving. Every one of these situations has to be trained separately. And this goes back to my idea of potentially there are other ways to train neural networks than the one that is currently being used. And I would say this is a really interesting research area. And if anybody else agrees, definitely contact me because I'd be interested in talking to you more about that. I love Andrej's term data triage. He talks about having to do intervention and having to find specific data. And it's an interesting medical term to use, triage, having to pick out the most important or most critically ill patients to work on first. It's kind of the same sort of thing with this data, is you got to find the stuff that's going wrong the most and fix that first. So obviously what most people know about is the intervention triage, which means that if a human being has to take over driving from the full self-driving computer, they flag that and they send it back to the mothership. But super interesting also is the bounding box flicker.
But there's many triggers that are active at any point in time. As one more example, if you have a detection of, say, a stop sign or something like that. So you have a bounding box that the computer is putting around the stop sign. And if the stop sign detection flickers, for example, so it's there and then the network says, oh, it's not a stop sign. Oh, wait, it is a stop sign. When you see this disagreement with itself over time, that also is typically an extremely good source of data. So flicker and temporally inconsistent predictions, or for example, disagreements with the map. So we think there's a stop sign, but the map says that there isn't one. So there's lots of different ways by which we gather examples where the network is mispredicting. And for us, it's an exercise of how quickly can you enter those examples into a training set. And that's a huge portion of what the team is doing.
So this is really cool. And this has something to do with the 4D-ness of training, which is that if you've got a box that says stop sign, stop sign, stop sign, blank, 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 stop sign, there is an automatic flagging of that and sending that back to the mothership saying, why did it lose the fact that this was a stop sign for those 3 frames? That's super cool because that means it's working over time and they're very specifically training for persistence of memory. They want the computer to be able to remember these things. And so training on specific data sets where it's losing track of something is fascinating, super useful. That's probably one of the main reasons why they're actually making such big progress right now. Andrej also talks about how they're sourcing mispredictions at scale. So that's an actually fascinating idea. It's like, you don't just need to know where things went wrong. You need to be able to know where everything, like massive amounts of that stuff happened, because you want to scale that up to a big amount where you can train on that at large scale and make progress quickly. Speaking of which, Karpathy says that the training cycles are usually limited to 2 to 3 weeks. And Andrej says that this is a psychological thing because no human being is willing to wait longer than that, which I think is hysterical. But basically what that means is that you've got bigger networks work better. And that's true because an arbitrarily large neural network can model an arbitrarily large function. But bigger networks require bigger models, which require much longer training, which require much higher compute rates. And so, you've got that sort of 2 to 3 week window limit. And so you've got to be able to squeeze as much into that as possible. The cool part, as Karpathy notes, is that humans are no longer the constraint in this loop. We were when we had to figure out explicit algorithms for every single part of full self-driving. But now that we have a neural network architecture or brain that we can train, the constraint is really data labeling, and data curating, and data crunching or compute speed. Finally, Karpathy talks about an industry bifurcation. He talks about the Waymo version, which is HD maps with tons of sensors and basically riding on a rail, Or the alternative is vision just like human beings, which is what Tesla is doing. As Karpathy says, the beginning of this is much, much harder, but you can scale it super rapidly when you get to a certain point. And that's kind of where they are. They're kind of like on the S curve right now, right? The other one had an S curve that was much earlier, but it tops out. Their S curve is much slower at the beginning, but then it goes vroom like that and takes off really quickly. Another interesting thing is that Peter asked Andrej about whether he's ever surprised by the neural network. And Andrej said, yes, every day. And as a researcher who does this stuff, I do understand that. Sometimes I'm just fascinated. I'm like, how did you get that, right? Because it is to some extent a black box, and the fact that it makes the right decision sometimes is like mind-blowing. So it's very, very cool that even Andrej Karpathy, who's in this all the time, is surprised by his own network. And Karpathy talks about how to reduce the data needed, which is a great thought. This is the major issue with AI training. If we can make it more human, things could really open up. And that kind of turns it into a general AI where it's actually doing cross-teaching. It's learning from one thing to another. And that's a little scary, right? Because that's where something could become potentially conscious. But anyway, the idea that we could, with only a few examples, he talks about a fire hydrant. He says, if we only see a few fire hydrants as a human being, we can kind of understand what they are. Whereas a computer needs tens of thousands of those cases to understand. So if we can make a system that teaches more like a human being, where we need fewer examples and we can cross-learn, because we already knew, what other objects were, we can learn what a fire hydrant is much more rapidly. So anyway, that's a really fascinating idea. And again, I think that's a really cool area of research that people could go into. And to wrap this up, Andrej talks about being overtaken by a problem. And I love that. Those are the most frustrating, but the best ones. He says he would sleep at the at Tesla's headquarters and just be completely overwhelmed by this problem. And I've had that happen to me many, many times. It's very frustrating. You're banging your head against it at 3 o'clock in the morning, but it leads to the greatest breakthroughs. I also love that Andrej is a teacher. I think that's so cool, and I really approve. And I really approve of the fact that he talks to everybody about the stuff that he's doing. So thank you, Andrej. Thank you, Peter. This was an amazing interview. Go listen to it for sure. Okay, I hope you enjoyed this episode and found it fun and informative. If you did, definitely like and subscribe so other people can find it. Also, as always, a huge shout out to my patrons on Patreon. Thank you all so, so much. And don't forget about our merch store, which is online now. You can get a Don't Mess with Tesla t-shirt and a whole bunch of other stuff, so definitely check that out. And don't forget, we are both Tesla and Amazon affiliates. If you look in the description, you can click on a link, go shopping, and help out the channel. Thank you. And as always, don't forget to ask me questions in the comments or at my email address, which is drknowitallknows@gmail.com. Till next time, bye-bye.